Hi guys, good morning. Thank you for tuning in to my channel. So today's subject, I would like to talk about I/O ports on the PIC 18F family of microcontrollers. So hopefully I will remember to leave a link in the description below for the PDF for the 18 series MCU Family Reference Manual. It's 976 pages. I suppose you could say it covers everything, and yet it will leave you wanting more, and you'll want to go look at other YouTube videos on every subject it discusses, because it can be very technical and it's not always geared to taking the student through projects step by step. So I am not an expert on PIC programming. I'm a student myself, but I've been studying PIC chips for the last 3 years or so, so I think I do know a thing or two about them, but I don't want to pass myself off as an expert because I am liable to get things wrong, and there might be things you know better than me. When I create videos, I make them for me. I make myself memorandum videos on subjects like the stack, the program counter, assembly instructions, the status register, and I make videos of me using the chip so that I don't forget what I had learned in the first place. So that's exactly what this video is. It's not me teaching, it's me creating a memorandum for myself, and it's me fumbling through the learning process. So here in this manual is a typical I/O port. I think if you're looking at a data sheet that is specific to your 18F chip, whatever that is, I think you'll find it's probably the same. And what I'm going to try and do today is just study it and sort of just look at it and discuss it out loud, right or wrong. Hopefully I don't add any errors into the discussion, but it might happen. On page 94 of the 18F Family Reference Manual, under the section on architecture, I believe. Let's make sure I got, it shows the relationship between a lot of different things. You know, the ALU, the program counter, here's the ROM, here's the I/O ports, here's the oscillator, here's the RAM. But anyway, if today we are discussing how the ports work, I really only want to study this to the extent where we can see how everything is related and connected to the ports. So here's port B, and here's a data bus connecting everything. So I wish I could explain this better. Maybe I can't. I've studied things individually, but I don't want to put an error in my video. But anyway, in a roundabout way, as the program memory is brought in through the program counter, latched in, and instructions are sent out to the ports, instructions can be written to the ports, but there's not enough information here to really understand what's happening inside the port. I think I read somewhere that on default reset or a power-up, the ports are default as inputs. So I guess that instructions that are being written to the tri-state register inside the port is going to determine whether it's an input or an output. So this is a good time now to turn from the general enhanced MCU block diagram to a typical I/O port diagram. Once again, I'm studying this out loud. I'm not speaking from the position as an expert. So I squeezed the general introduction and description onto the same layout so I can read this and hopefully, well, this is visual. Well, this is appearing here at the same time, it'll make more sense. So I am reading verbatim, but general purpose I/O pins can be considered the simplest of peripherals. This is what it says. So I am just assuming without looking into it that we're calling the pins, the pinouts, peripherals. Maybe I need a better definition of what a peripheral is, but I think it's obvious enough. They allow the PIC microcontroller to monitor and control other devices. Well, if you're going to monitor something, I suppose you would have to configure your I/O port as an input, and if you're going to control another device, well, I suppose you would configure your port pin as an output. To add flexibility and functionality to a device, some pins are multiplexed with an alternate function or functions. Maybe you've seen that all of the pins share various different functions. For instance, PGD, PGC, PGM all relate to programming your chip from your PC, and then you've got these pins are devoted to the oscillator to create a clock for your microcontroller. So that's what this is saying when it's saying the pins are multiplexed with alternate functions. These alternate functions depend on which peripheral features are on the device. In general, when a peripheral is functioning, that pin may be used as a general purpose I/O pin. For most ports, the I/O pin's direction, input or output, is controlled by the data direction register called the trice register. The tri-state register controls the direction of the port. A1 in the trice bit corresponds to that pin being an input, while a 0 corresponds to that pin being an output. An easy way to remember is that a number 1 looks like a letter I for input, and a letter or a number 0 looks like a letter O for output. The port register is the latch for the data to be output. So I'm just asking, because I don't know, which latch are we talking about? The data latch Are we talking about the data latch or the trace latch? That's a question for you, the listener. So which one is the port register? The port register is the latch for the data to be output. Okay, when the port is read, the device reads the levels present on the I/O pins, not the latch. This means that care should be taken with read, modify, write commands on the ports and changing the direction of a pin from an input to an output. Well, I'm just thinking this one through. This here is the I/O pin. So it's distinguishing a read taken from the latch, whichever one these that is. It's saying it takes the read directly off the I/O pin. Figure 11.1, which that's what this is, shows a typical I/O port. This does not take into account peripheral functions that may be multiplexed onto the I/O pin. Reading the port register reads the status of the pins, whereas writing to it will write to the port latch. Well, to me, if you're reading from the port, you've configured it as an input. But to me, if you're writing to it, it's probably more likely that you've configured the port as an output. But what do I know? Maybe I'm wrong. But when you're writing to it, you end up writing to the port latch, according to what it says here. All write operations, such as bit set F and bit clear F instructions, are read, modify, write operations. Therefore, a write to a port implies that the port pins are read, or read. Okay, so I don't understand the last sentence, but I'll read it anyway. How do you like to watch a video where a guy doesn't exactly know? Therefore, a write to a port implies that the port pins are read. This value is modified and then written to the port data latch. Well, this is the port data latch. Just break this down. Reading the port register reads the status of the pins, whereas writing to it will write to the port latch. Therefore, to write to a port implies that the port pins are read. This value is modified and then written to the port data latch. Alright, how am I doing? So, I'm going to label some of this stuff. So this to me, let's get an orangey color. This to me looks like a buffer. If it had a little circle on the tip, it would be a NOT gate, but it's not. Here's another one. And another one. I do know what triangles look like. So just as a refresher for those that don't know, this is a buffer gate, and the input ends up being the same as the output. And just so I don't get it wrong, so what does a buffer do in electronics? Electronics circuits whose primary function is to connect a high impedance source to a low impedance load without significant attenuation or distortion of the signal. Thus, the output voltage of a buffer replicates the input voltage without loading the source. But in logic gates, buffer gates merely serve the purpose of signal amplification, taking a weak signal source that isn't capable of sourcing or sinking much current and boosting the current capacity of the signal so as to be able to drive a load. Buffer circuits are symbolized by a triangle symbol with no inverter bubble. So yeah, I knew that. I didn't need to look it up, but just to make sure that you learning understand it as well as I do. So let's get rid of that question mark. These are buffers. And if I had to put things into my own words, I would say that it's just strengthening the signal in the circuit, sort of like sustaining the signal. Okay, so next, this glands-shaped device is an OR gate, I believe. Here is an AND gate, and these are not gates here. So this is the power, most likely 5 volts. And to me this looks like the negative voltage supply, most likely ground. So I've been looking through the reference manual for a definition of WR port, and it certainly shows up in all the port diagrams, but it doesn't ever give a definition of what WR port means. Like, I'm thinking it has something to do with the working register. Oh no. Architecture, I/O descriptions. So WR shows up here. Write control for parallel slave port. Well, maybe it just WR just means write. So yeah, I guess I'm learning stuff myself. So WR port maybe means write to the port, write to the tri-state register, and then I guess maybe this means read the port. So I don't know if I can say the following correctly, meaning I don't know if I'm about to include an error in my video, but to me, and you judge whether you think I'm right or wrong, that's the test. So if a pin, an I/O pin, is designated as an output pin, then you write to an output pin, don't you? But if you're going to read from it, you read from an input pin. So maybe these two, WR port, WR trice, maybe this is to when you're configured as an output port, you're going to write to these, and so maybe when it's an input, you're going to read the port down here. Tell me if I'm wrong. But I'm just working through this kind of through a process of elimination. So here's the I/O pin. What's connected directly to it? Well, you've got a transistor. What do you call that type? CMOS? Anyway, I suppose you could, yeah, it's got, well, anyway, let's just say this is an input, set up as an input. I guess you've got the I/O pin coming in here through this TTL or Schmidt trigger. To me, that's a buffer. Okay, so I'll use the purple. This is going to decide whether a pin is configured as input or output. That's what the trice register does. So to me, that's what this is doing. Okay, just reading this definition. Reading the port register reads the status of the pin. We're reading here. Whereas writing to the port will write to the port latch. So the best thing I can do at this point is leave a skill testing question as to whether this is the port latch. I'm going to do something here. This is read. But this also says RD lat. Okay, bear with me here. So I already read this oops. Oh dear. I already read this information in here as we were looking at the chart. So I got some more stuff out of the reference manual here. Here we go. This pertains to the output data latch and data direction register. Allow me to read. All port pins have an output data latch. I guess that's what that is. Writing to a port writes to that latch, lat X. The data latch may also be read from and written to directly. If the pin is not being used by a peripheral and is configured as an output by its trice bit, data in the latch will be output to the pin. All port pins have corresponding data direction register bits, trice X register, which configure each pin as an input or output. Clearing a bit in a trice register, example bit equals 0, configures the corresponding pin for output and drives the contents of the output data lat X to the selected pin. Setting a trice register bit B equals 1 configures the corresponding pin as an input and puts the corresponding output driver in a high impedance state. After a reset, all pins are configured as inputs. See, I started the video off with that, so you know I'm not lying. Example 11.1, which is not this, shows that writing the value in the WReg register to port B actually writes the value to the lat B register. See, I've been going through this reference manual to find insight as to how this circuit's actually working. But here I'm showing on the screen, I guess this is for an analog input. At first inspection it looks generally the same, except there's this AND glands, analog input mode. And then there's some difference on this RA4 pin as opposed to the rest of the bits in port A. It's a Schmidt trigger buffer. I forget what the purpose of that is. What does it say? All other port A pins have TTL input levels and a CMOS output driver. I guess I can add this is a P-type CMOS transistor, and this is an N-type CMOS transistor. I mean, and then these knobs here are going to be triggered by highs generally. Hold on. So I thought maybe I'll color code these lines going into the OR gate here. Just trying to think this through. Okay, so we know with an AND gate that when it needs two highs, it needs a 1 here and a 1 here. And with an OR gate, it needs a high here or here. It just needs a single high. Okay, I think I may have discovered something. So this is the data bus, and I suppose when the data bus is sending in some applicable highs or lows, then when the port is written to, it'll go from a high to a low. Okay, so assuming this is configured as an output, then a positive high can be sent out to the I/O pin if it gets a high here or a high here. This wasn't a very good video, was it?